Alright, welcome back. So, making another video this morning. I want to start off the video with something kind of cool. So, part of what I do on this channel is use ChatGPT quite a bit. And there are a lot of really novel and creative ways you can use it. And one of the ways I've found is to create a tier list. And you can do that for anything. So, for example, this is an early morning video because I woke up at about 5:30 and couldn't get back to sleep, which I guess some would say is a good thing. And I asked ChatGPT to create for me a tier list of things I could do with this extra time now that I'm up so early. And the S tier was exercise. That's the first one. That's always really important. I don't think there's any doubt about that. And then the next one was reading. So I'm going to continue this series now to make an S tier choice. And we can see there's all the way other tiers. So like that's I think a really good way to prompt. Let me just while the book is loading here, give my three top prompts for ChatGPT. The first one is evaluate this claim, and then in the quotes you put any claim you hear anywhere. You ask it to evaluate it, and it's not going to be perfect in doing this, but it'll give you a general sense of the claim to go in and do more information from there. It should identify if the claim came from any bad actors that are known for giving false claims. Hopefully. Hopefully it will do that, but it still kind of has a long ways to go when it comes to this sort of prompt, but I think it's better than not in most cases. And then it doesn't tell you the truth, it tells you the consensus based on its training data. So that could be true, it could not be. There's definitely wisdom in the crowds, but sometimes the truth is not very widely known. Then the other one is act as an expert in the blank knowledge domain, or in the knowledge domain of blank. Create a tier list of blank. And then the final one I like to do is assign a letter grade to blank. And blank can be a lot of different things. If not an A plus, provide feedback to improve the grade. So these are my top three ChatGPT prompts. And you can get creative with these. For example, I was in the park and I got bit by a dog. So I had it assign a letter grade to that response. So it was kind of a traumatic experience for me. So it was a really good way to kind of deal with that trauma, which was to do a post analysis of the whole situation and really come to, because in those kinds of situations, the thing that really kind of causes trauma for me is like, what was I supposed to do? I had no idea what to do, and I don't know if I did something wrong, or like, it makes me feel so out of control, and like this situation could happen again at any moment in the future because I'm somehow doing something to provoke these kinds of situations. So in this discussion with ChatGPT, no, that's not the case. The dog's just kind of freaked out for whatever reason. I acted in a B plus way. I could have gotten an A if I, instead of turning my back on the dogs as they attacked me, tried to make myself look more threatening. If I gotten the contact information from the owners, and if I had filed a city report in a timely way. So, but knowing that I acted in a B plus way and I'm not just acting in an F minus way all over town and enticing dogs to attack me was very deeply therapeutic. So I just wanted to share that. All right, so getting back on topic here, we're on the final use case. So the prior video, we switched over to Google Colab. We were able to run the notebooks from there. A few issues there, and we saw how much power it really takes. It takes a lot of power. It takes well over 20 gigabytes of RAM. I have 16 on my computer, so yeah, not enough. All right, so moving on to the final use case 10. That router is not properly configured. Pain point. This is a use case that I love because it addresses a pain point that I think is really significant across almost all network infrastructures. How often have you found out that a problem in your network was due to something not being configured in the way it should? This is definitely not news to you. This is a prevalent problem network teams have been dealing with and trying to solve in the best way possible. Yeah, and honestly, it's not even a lot of the times someone just making a mistake. A lot of the times what happens is the configuration isn't saved properly. So if there's a reboot, the device boots up to either a blank config or a prior version of the config that doesn't contain all of the necessary changes up till now. So this is a prevalent problem network teams have dealing with and have been dealing with and trying to solve in the best way possible. Even if you have configurations generated automatically by provisioning systems, chances are at some point someone modifies the configuration manually as part of a troubleshooting process and misses to revert that change back. Yeah, that's a big one too when you're really troubleshooting something. But I think that one's kind of not as common because if you're troubleshooting something, presumably the end result would be you fix the issue. So I guess, I don't know. Historically, configuration management tools are deployed, allowing you to define so-called golden templates. Those are configuration rules or templates that specify for a particular device vendor and probably role in your network how a particular portion of the configuration should look. Interface template, BGP template, OSPF template, etc. The expectation is that this tool will frequently track configuration changes and evaluate them against the relevant templates, verifying compliance. If this is a solved problem, why tackle it here? Well, it is a solved problem if you have such a configuration management tool, if you have templates for everything in the configuration, if those templates are up to date, and you have this for all vendors in your network. Then maybe you are covered. The pain point is there. How to identify if something is not configured as it is supposed to be. And yeah, the author points out that you can solve this problem by building a configuration management tool or deploying one that's kind of already been built, like Ansible can serve as one. So yeah, it can be a solved problem, but the configuration, yeah, but this can be a part of that tool. Approach. We already know how to solve this by employing rules or templates. Is there any alternative or contemporary approach? There is, and machine learning and NLP, natural language processing, are here to help. This is the last use case and our last example of leveraging NLP techniques. The previous NLP examples used syslog messages as the data source. In this case, we will use configuration data, specifically configuration files. Network element configurations are ultimately a manifestation of a natural language, one that is intended both for machines and humans to read. It follows specific grammar and syntax rules, and when applied in a specific network context, follows some customer specific rules. As a form of natural language, the same techniques used for other natural languages, such as Spanish, uh, English, Spanish, etc., are applicable. The advantage here is that any of the languages we will need to deal with, Cisco iOS, Juniper Junos, Nokia SROS, Arista AOS, are much simpler, with a shorter vocabulary and more straightforward rules to learn. However, what can we do? We can build a language model. A language model is a machine learning model trained to learn the internal rules of a language. It is usually trained to predict what word is more likely to be in a particular position of a sequence. In the learning process, it implicitly learns many of that language's grammar and syntax rules. Consequently, if a sequence is introduced with some word in a position it is not supposed to, the model can detect this and raise it as an anomaly. This is a common practice in many fields of applicability of natural languages. This is precisely the approach we will take. We will build and train a language model with the configurations of the devices in the network for which we want to track anomalies. Once trained, the model will have learned the rules for those configurations, both generic and specific to the context where they are being used, your network. Once the model is trained, we can run through the model any configuration file and obtain what parts of such configuration the model finds anomalous. That process will happen without explicitly defining any rule or building any semantic awareness of what each part of the configuration is about. Interfaces, BGP, OSPF, etc. Alright, and I feel like I do need a small break, so I'll take it before I need it even more. Alright, I'm back. Let's chip away. I'm a little bit, not quite. This is a bit much. The problem with those S tier things is it assumes that you wake up in a good enough state to go out and run a marathon. Alright, so note that this approach is entirely vendor agnostic, but that does not mean you can train the same instance of a model with configurations of multiple vendors. And sorry, I need to get on my treadmill. That will fix things. Okay, there we go. Alright, feel a lot better now. In fact, you can, but you probably should not. Nothing prevents a model from learning multiple languages. There are large language models that support multiple languages, but that is only possible when there is enough available data. In our network configuration scenario, it would be better to have different instances of the model, each trained with configurations from each vendor. Note, however, that no vendor-specific intelligence is required from our side. At the end of the day, a configuration is simply a text file. This is how we will process it. The approach described in this use case is based on existing public research. See 35 for reference. Input data. Finding a dataset of network configurations is not easy exactly, at least if you do not have access to a network. And even if you do, you only have... See, this opens a whole can of worms because, you know, there are a lot of different kinds of networks. There's campus networks, there's service provider networks, there's data center networks, there's even more networks than that, and there's special there's different design considerations and trade-offs and choices that you can make on a network. So even if you have a service provider network, it's not going to look the same at all from one service provider to the next, because, for example, the decision for which protocol to use for your IGP, I would say ISIS is probably the best decision, hands down, but you never know, who's going to make a different decision than that. And you might think, oh, well, that would be stupid. You have to use ISIS. Well, again, it's very specific network for very specific use cases. So maybe it makes sense to use OSPF. Like, you can't really have a one-size-fits-all network. You have to make decisions that make sense for your specific use case. A really good example of that, and I guess I need to be careful not to so here's an example. Here's a great example. So you have a device in your head end, then you have a like a layer 2 device here. So you have the layer 3 pipe here. You have the layer 2 device. You have devices coming out from here. Well, here's a great example. So you could have these devices connected to each other without going up through this port, because this is a switch, so you could just switch them from there. So that might seem like the obvious solution. Why send it up here and down there necessarily? Well, you know what the answer could be? Visibility. Your monitoring tools can only plug into a layer 3 port. The amount of the traffic engineering of it, the speed of the traffic, it's going to look more or less the same. It's indetectable difference whether it goes through the absolute most possibly optimal route or whether it just kind of goes up another link unnecessarily. It's really just going to be a very small, undetectable performance hit, if any form of performance hit at all. And then you have the visibility here in your software here that monitors your network that you don't get when it's down here. So like, it's not just about the performance of the traffic. It's not just about what is the simplest way to do this. Sometimes it's about what features do we need. We need to track this. We need visibility into the traffic statistics in a way that can be captured by our tools. So we have to do it in this way that to an outside observer, they would be like, why, this makes no sense. Well, it doesn't make no sense if you don't consider, it doesn't make any sense, that's true, if you don't consider the broader picture and the broader ecosystem it belongs to. It makes perfect sense when you consider that we use a tool to collect information, and the only way we can collect information is by configuring it the information we need is by configuring it in this special way. Then it makes a lot of sense. All right, so input data. Finding a data set of network configurations is not easy, at least. If you do not have access to a network, if you do not have access to a network. And again, even if you do have access to a network, you have access to a very specific network that's not necessarily directly applicable to other networks, especially other networks of vastly different types. If you are a network engineer with access to your network configurations, I would encourage you to try this case with your own. But since I do not have access to configurations, I decided to leverage SANS to generate the configurations we need for this use case. In SANS, it is possible to define a configuration template. You can find the example we are using in our use case on the use case folder. config_template.txt. A configuration template is nothing but a configuration with a method to define where and how to replace certain parts of the template with actual variable values for a particular instance of a device. With this method, we can request SANS to generate configurations for the devices we request from its inventory. It will generate based on the golden template the common parts as well as the interface specific parts. It is not perfect, but it is good enough for the purposes of the use case we want to illustrate. We are going to generate configurations following the referred template for all PE devices. In general, the recommendation would be to train this model with configurations that are supposed to be homogeneous. You want the model to learn how a certain network element in your network should be configured, in this case, the PEs. If you mix PE configurations and core configurations, the results may not be as good. The model may still be able to learn and differentiate between the different types and learn the rules within each type. But in general, more data will be required, and there are more chances that it may not differentiate properly. Whereas if you train them separately, you could have better chances of success. You could argue, couldn't we build a model where we push all configurations from all rules, from all vendors, and the system goes and learns them all? Well, it is possible, but unlikely, unless you have a very, very, very large number of configurations that the model has the opportunity to learn all those differences. You may try in your network different approaches. My recommendation is to start with only homogeneous devices. For this reason, in this case, we are only training with configurations from the PEs. The SANS command will produce the following output. And that's a good point too. You know, networks are very specialized. It's like you can't train just kind of, you know, on anything and expect it to work anywhere. There are specific devices in a network. There are route reflectors, there are provider edge devices, there are core devices, and if you train on a route reflector, you're not going to get the config you need. So you really need to know what you're doing, and you have to be able to know whether or not the AI was correct. All right, so we're going into another playbook. So I'll advance the bookmark beyond there. And let me try to see where this playbook is, because it's not here. So I don't know where. Yeah, I don't know what I can do about this one, because I've only got it up through UC9. Oh, you know what? I do have UC10 right here. Oh, I don't know why I didn't see that before. Oh, because it was out of order, I think. Okay. All right, well, that's good news. We can use UC10. Hopefully we can do it locally. That's UC9, so I'll collapse that. There you go. And now this is UC10, so we open this. And then, Jupyter Notebook. Good. Yeah, so it's out of order. I think that's why I missed it. All right, and hopefully I can do this one locally. We'll try it. Yeah, let's try this one locally. And I might have to keep. You know what? I think I can just take another break. I'm thinking I might have to make this one shorter. I don't think I can do more than an hour. Yeah, exercise and reading a book, perhaps doing what I'm doing, which is kind of both at the same time, is an X tier activity, but I feel like ChatGPT assumes that you're capable of exercising or reading a book when you wake up super early. In my experience, usually not quite that capable. I'm going to pass out if I try to do any heavy exercise. All right, but yeah, you know what? Let me pause it. I'll be right back. All right, welcome back. I'm not sure how much longer I can do. Let's try to get this going here. So we have to change it to run locally, which might not work. All right, so now we need it to be the path files here. All right. And then we need an additional one here. So like that, and then like this. There we go, that should work. We need to change this statement. All right, and let's clear the notebook widget state and then restart and clear output. All right, and then let's do it from blank slate. Tabula rasa. All right, and this is our first big cell. We're generating a data frame. Aha, and it went perfect. So generating a data frame can take some time, but it looks like everything's working great. Yeah, so there's the data frame. The data frame contains one column with the device name and another column with a string object that contains the entire configuration. Note that I am using a simulated iOS-XR based template. You probably remember that the PEs were Juniper and some Cisco. It really does not matter. The template is just a text file. We are going to write the above configurations in separate files because this is how we plan to do the training. All right. If you do not want to generate new config files, there are pre-loaded configuration files for all PEs in the uc10/configs/folder. Either way, the goal is to have a list of configuration files as follows. This represents our input dataset. All right, so let's get to this config files here, which is right there. There we go. Problem resolution. This is a full-blown NLP use case. Neuro-linguistic, no, it's not neuro-linguistic programming, that's something else. It's natural language processing. And you can see where my brain's like not all the way there. I kind of haven't been reading this. I'm doing the thing where I read it, but I don't read it. Like I form the words, I do everything, but it's what's happening in my brain is different than what I'm reading, which usually means that I need to go and read it again because I just did not. I'm just going through the motions and I'm not actually understanding what I'm reading. But and that's a good tell when the acronym is mapped to something different. So this is a full-blown natural language processing use case. We start by each observation being a full document, a configuration file. We have 100 input documents to work with. Not all of them will be used for training, so we are going to split our files in training and testing. I want to make sure there are configuration files which the model has never seen that we can evaluate. Sometimes, depending on how you have captured your configuration, you might have in the same file certain data before that it may not be of your interest. You need to somehow define where the model should start looking to find the actual data for training. I have defined the following function for that purpose. Alright, and this looks like it's going to be a while, so I think it's just not my morning this morning. So I should definitely come back to this. At least let me just take another small pause here. Alright, I'm back. I feel like what I really want to do is just stop. Yeah, so this next one goes to the tokenizer. So that would be but here. Yeah, so it looks like this is going to work really easily. So maybe once I get down in the model stuff, it'll stop working as well. So I think this is a good time to stop. I'm just the words are coming in and going out, but really not registering at all. So yeah, that's the end of this video. Thanks for watching. Stay tuned for the next one.